Greetings, Fearless Leader here. I wanted to solve one of these homework problems with you, and you know that good problem solvers read the problem many times, so let's do that. Suppose you just received a shipment of 15 televisions. 4 of the televisions are defective. 2 televisions are randomly selected. Compute the probability that both televisions work. What is the probability at least one of the 2 televisions does not work? We begin with a tree diagram. We're going to start here, and we're going to consider our 2 possibilities. Actually, we're going to start here. Defective television, not defective television. There are 4 such televisions that are defective out of 15 total televisions, which makes this 11 out of 15 possible not defective televisions. Then, if we chose a defective TV, there would only be 3 defective TVs left to choose out of 14 total TVs, because these are independent events. Oh, sorry, that's not the right words. This is sampling without replacement. We do not put the television back after we choose it. This path, we had a defective followed by a not defective. So, of course, there are 11 not defective TVs out of 14 total to choose from. A defective TV and a not defective TV. Here, we still have 4 defective televisions, but only 14 total televisions. That means we have 11 non-defective televisions over 14 total. Oh, no, that's not right. 4 defective televisions, 10 non-defective televisions. That makes more sense. So, now, to find the probability that both televisions work, we have to find the appropriate path, which is this path. And since these are independent events, we multiply the probabilities. And that's 110 over, I believe that's 210, but I'm going to check it with my calculator. So I'm going to do 11 times 10, so I'm going to use parentheses. Parenthesis 11 times 10 divided by parenthesis 15 times 14, close paren, and I get 0.524 to the nearest hundredth, or nearest thousandth. And there it is. So, oh, wrong thing. This is the one I want. Nope, just kidding. This is the one I want. So 0.524 to 3 decimal places. 0.524. Ha! Now, this concept has been pretty difficult, this sort of at least one rule or property. So the probability that at least one of the 2 televisions does not work is on the tree diagram, and I'm going to use a different color here. I'll use blue. Notice that this path has at least one of the 2 televisions being defective. This path has at least one television that's defective. This path has at least one defective television. So that's the whole sample space. That's it. Which means the probability at least one defective is 1 minus the probability both not defective. So we know the probability that both are not defective is 524, and so that's the probability we want. So we go 1 minus 0.524, we get 0.524 476. Wait, what? Did I do something wrong? What did I do wrong? I'm so confused. Uh, 10 divided by 210. It's 0.524. Isn't that what I put? Oh, I didn't put a decimal point. That's why. There we go. Okay, so that's problem 6. That's how it's done. Hope this was helpful.